Welcome back. I hope you're having an awesome time so far. Our next speaker is Omri Geller. He's the CEO and co-founder of RunAI. Please join me in welcoming Omri to our virtual stage.
Hi, everyone. I'm Omri, co-founder and CEO of RunAI, a platform for virtualization and orchestration of AI workloads. And today I'm going to talk with you about what we're seeing at a number of our financial institutions' customers and their challenges around AI infrastructure. I assume that this will resonate with many of you. And of course, I will also walk you through a case study that shows how RunAI helped those customers to solve and overcome those challenges. So, as we all know, AI is growing significantly fast in recent years. And one of the main reasons is the fact that there are more and more data in the world and more computing power that is needed in order to run high compute intensive workloads that are AI workloads. And specifically, the financial vertical is very advanced when it comes to AI with financial modeling, algorithmic trading, risk management, and many more applications that run using AI models. And in order to run those AI models, you'll need a lot of compute. And usually, the compute is used in a specific accelerators and processors for AI, such as GPUs. So organizations and financial institutions in particular build new GPU clusters in order to enable the massive advancement in AI algorithms. But even though there are GPU clusters, there are still significant challenges that hold back organizations from bringing solutions of AI to market. And the question is why? Why, if we already have the GPU clusters that are so important to bring solutions to market, we still find ourselves waiting for so long to see results of AI models? In order to understand that, we need to understand the way that AI researchers and data scientists build AI solutions and the way that they consume compute power. Their compute consumption is dynamic, and basically, GPU consumption is erratic in enterprises because data scientists consume or need to consume different amount of GPU power at different times in order to satisfy their demand. And the reason is that data science is based on experimentation and running experiments in order to bring solutions to market. There are times that a data scientist need to run many experiments on many GPUs in parallel, and there are times that they do not need to use any GPUs because maybe they clean their data or that just does not need to run experiments. And what you can see here is an image from one of our customers and how 6 data scientists have used GPUs versus time so that you'll be able to understand the dynamic consumption of GPUs. You can see that user 2, for example, used around 16 GPUs in the first few days of the measurement, whereas user 5 didn't use GPUs for the majority of the time and then used a bursty large number of GPUs at the last week of this measurement. That means that it is very hard to predict in advance how many GPUs every data scientist will need. And basically, what happens time after time in enterprises and organizations is that the resources are allocated in a static way. It means that every data scientist gets a fixed amount of GPUs, which, as you understood in the last slide, holding back their science, since when they need more GPUs, they cannot get it. Let's take as an example a data scientist group of 3 people, Susan, Joe, and Gemma. And in that example, the GPU quota of Susan is 2, Joe gets 2 GPUs, and Gemma gets 4 GPUs. So overall, they share 8 GPUs. However, the allocation is static. It means that Susan is not able to use more than 2 GPUs, so as Joe and Gemma cannot use more than 4 GPUs. If we look at a specific point in time, we can see, for example, that Susan is using 2 GPUs, meaning she is using all of her quota. Joe is not using GPUs at all, and Gemma is using 2 out of her 4 GPUs. Overall, 4 GPUs are in use in the cluster out of the 8, and 4 GPUs are free. However, due to the static resource allocation, Susan cannot get more than 2 GPUs, and she may actually take over and would like to run on more than 2 GPUs in order to run more experiments and bring her solutions to market, but she cannot do that because she's statically allocated to her 2 GPUs, which leads to a lot of hassle since data scientists always need to go for IT to ask for GPUs, and they actually don't know that there are free GPUs available for them to run more experiments because they do not have access or visibility into those GPUs. So that's actually the case with most enterprises, leading to a significant underutilized deployments. Usually we see GPU deployments of around 20–25% utilization of those clusters. And then on the one hand, there is the IT organizations that invest significantly in very expensive hardware in order to build AI solutions. But on the other hand, also the data scientists, the researchers, are sitting and waiting for resources in order to be productive and run experiments. So everyone loses. Data scientists lose productivity because they do not have access to GPUs when they need it and as much as they need. And IT organizations do not get full utilization of their expensive investment in resources. RunAI actually solved this problem by taking organizations from a world of static GPU allocations and instead provide a dynamic system that provides the right amount of GPUs for every user or team at any time so that they can perform their science much faster and bring solutions to market faster. The way that we do that is by building an orchestration and virtualization platform that efficiently share GPU resources between the different teams and users. We do it by pooling together all the resources into one large pool of GPUs, and then dynamically allocate GPUs to users without limiting them to a static quota of GPUs so that they can actually get much more GPUs than they get the right amount of GPUs at any point in time. The way that we do that is by using a concept we call guaranteed quotas that actually allows users to consume more GPU than their quota if other users are not using their GPUs. So in our example, if the user that had a quota of 2 GPUs would like to use more GPUs and there were available GPUs in the cluster, RunAI system will allow that user to consume more GPUs, run more experiments, and bring solutions to faster to market. The way that it is implemented is by a scheduler that, based on priorities and policies, actually knows how much GPUs to allocate to different users at different times. And in that way, we can help data scientists run much more experiments at any point in time, get much more GPUs, and help IT organizations to maximize the investment on their AI infrastructure. That way, we can actually bridge the gap between the data science teams and the IT teams. Data scientists gain productivity and speed since they get, if you like, unlimited compute, unlimited GPUs. And on the other hand, IT organizations gain visibility, control over the resources to be aligned with business goals, and maximal utilization of GPUs. In this slide, I want to start and walk you through a use case of RunAI and how we help our customers to get the most out of their GPUs and accelerate their science. So what you can see here is GPU consumption using the RunAI system versus time of multiple users. You can see that user 6, for example, in purple, actually used 16 GPUs to probably run 16 experiments in parallel, or maybe to run multiple experiments on multiple GPUs for about a week. And afterwards, the GPU consumption reduced significantly. Whereas if you look on, for example, user 9, you'll see a very bursty GPU consumption around the middle of this time measurement, and user 11 that actually used more than 20 GPUs towards the end of the measurement. Using RunAI and our guaranteed quotas concept, we allow the users to go over their quota, over their GPU quota, when other people haven't used their GPUs. So you can see, for example, that user 6 at the beginning was able to get around 16 GPUs because many other users did not use as many GPUs at this point in time. And if you look versus time, you'll see that RunAI automatically load balance and share the GPUs such that every user got the maximum amount of GPUs that they can at any point in time. This dynamic workflow removes hassles from data scientists around how they allocate GPUs for their science. In that example here, you can see the UI of RunAI that shows that many workloads have been submitted by one researcher. Actually, 50 jobs at this point have been submitted by one researcher to the cluster. So that user can actually run many experiments in parallel, and with that, accelerate the science. However, not all of his or her jobs were running concurrently, because the cluster has 40 GPUs, and there are other users that are actually sharing the cluster, and we want to provide them with access to GPUs. Therefore, some of his or her jobs are queued and launched when resources become available. That actually free up data scientists from thinking about the underlying GPU infrastructure. They can just submit as many experiments as they like, and RunAI system will automatically provision those workloads, their experiments, where there are free GPUs, effectively allowing them to run much more experiments per given time and hardware, and helping the organization to be much more effective when it comes to bringing AI solutions to market. You may be asking yourself, what happened if the cluster becomes full and many people that are already over their quota ask for more GPUs? So here comes into play another very important concept of the RunAI system. We call it fairness. And fairness is actually coming in order to make sure that no user or team will suffer from starvation for GPUs. And with using this feature, we can actually provide fair share of the cluster at any point in time to every user and every team. What you see here is a situation where the cluster was full, all the 40 GPUs were actually running workloads. And you can see that user 11 in blue was actually using around 20 GPUs, which is great, much more than his or her quota, because other users weren't using their GPUs, and the system was able to provide more GPUs to user 11. But then user 7, that constantly use around 12 GPUs, asked to run more GPUs, more workloads on more GPUs. So what our system did, and you can look at it at the black cube that represent the fairness, in order to be fair, it took back some of the GPUs of user 11, provided to user 7, and allow user 7 to consume more GPUs. And then when user 7 actually, and when the jobs and the workload of user 7 ended, you can see towards the end of the black cube with the fairness that user 11 got his or her GPUs back. And the system managed everything automatically based on presets, priorities, and policies. So using that capabilities, the system knows how to provide more GPUs to users when they can use it, but it also knows to automatically preempt some jobs based on presets, priorities, and policies when other people need access to the cluster, so that there will be no starvation and every user will be able to use the amount of GPUs that they need at any point in time without creating challenges for other users. With that system, that organization was able to significantly improve the productivity of their data science teams. They actually saw that by running on those idle resources that without RunAI were sitting idle without any job running, they could reduce their time to market from 46 days to building an algorithm to only 2 days. The way that they did it was by allowing their data science teams to run much more experiments over a given hardware per time. And as I mentioned earlier, by allowing your data science teams to easily run more experiments, you can significantly improve their productivity as data scientists. And that will lead me to my next slide that talks about another cool feature of RunAI that significantly helped to increase utilization of GPU clusters and bring solutions to market faster. That feature is RunAI's Fractional GPU. That means that we can enable to run multiple jobs on a single GPU so that you can actually run much more experiments per given hardware by running many experiments on a single GPU. Every experiment can consume a fraction of the GPU, a fraction of the GPU memory and compute. And in cases where your experiments do not need a full GPU, that can significantly improve, first, the utilization of the GPUs, which is important, and second, the amount of experiments that users can run. So we've actually seen many of our customers running 4 to 8 workloads or experiments on a single GPU. And in one occasion, we actually saw one of our customers running 7,000 jobs on the GPU cluster, where each of the job ran on 20% of the GPU. And as you can understand, they were able to run much more experiments per given time and be much more efficient and productive. So that feature is super helpful to manage your GPU cluster, increase utilization, and improve productivity for your data science teams. As you may have seen, RunAI resource management layer provides a supercomputing powers to every researcher fingertips, which make your data science teams significantly more productive and helping the organization to bring AI solutions to faster to market. To summarize, today I spoke about the challenges of static GPU allocations and how it can hold back from bringing innovative AI solutions to market. I then showed you how by providing the right product and technology, you can maximize the efficiency of your infrastructure, increase utilization of GPU infrastructure, and speed up the experimentation processes and time to market for your data science initiatives. We'll be happy to talk more about it if you'll visit us at the booth or at our website, www.run.ai. Thank you.
Awesome. Thank you so much, Omri. We really appreciate you sharing these incredible insights with us. The audience is giving you a big virtual round of applause.
Thank you.
All right, for the audience, it's time for you to make your way to your next session. Along the way, make sure to accept your connection request and check out our AI exhibits. Thanks so much, and we'll see you around.
Awesome. Thank you.